input in my career. And I grew up on his books, and I hope he will provide additional resources to engage me and to put more value to encourage me to learn more about network. And thank you so much, Kevin.
Kevin's continuous release of different content. He likes to touch on different subjects, like his Python 101 and just the various collaboration stuff that he does. I enjoy how he continues to just try to help students learn, and he develops a methodology for it, like his book, Career to Success. When he released that, I was one of the first ones to buy it, and it really helped me on how to develop my own framework to further my own career. And anytime someone wants to get advice on how to move their career forward, I recommend this book to them because I think it's a really good purchase, a really good thing. I've been doing or working with Cisco collaboration since 2007, and I was not really looking into any Cisco certification. I was just like a guy working day to day, and then as one of my friends introduced me to all the Kevin policy material and training program, then that kind of motivated me to try and attempt all this CCIE collaboration certification. And last year I took the first two exams for CCNA, and now it's like and then I passed both of them first time, and that was great. And
I started to follow Kevin Wallace probably about 7 years ago when I changed from the voice sector. I'm an old TDM voice guy, so a lot of his explanations just made sense to me. And because of that, I feel that I've just been drawn towards his style of teaching, which has been very beneficial to me.
Welcome everyone to sort of a spontaneous webcast I decided to put together. It's going to be about 30 minutes, just guessing, and the topic is quality of service, specifically how quality of service marking works. And this is kind of leading up to a huge event coming up on Wednesday. I know some of you have already heard about it. I saw you chatting about it. But coming up on Wednesday, here's what's going on. I decided that I'm going to create, it's been a long time since I created a QoS course. I mean, it's been a very, very long time. And I thought it's time to update that. I want to create a brand new quality of service masterclass, and we're going to be selling that on my website later on. However, I thought I'm going to be shooting this course anyway. Why don't I allow my followers on Facebook, YouTube, wherever to kind of just tune in, watch behind the scenes for free? So that's what I've got for you. There's the offer before we jump into today's training. If you would like to join me for free, it's going to be, I don't know, 3 to 4 hours, just guessing, on Wednesday. We're going to do a QoS masterclass covering every QoS topic on both the CCNA exam blueprint and the Encore exam blueprint. QoS shows up on both blueprints. Oh, and I'm also developing training for the collaboration track. QoS is on there too, so it's going to help you with the collaboration track, with Encore, for CCNA. And it's one of the more challenging topics for students. And I've noticed that Cami or Kami said over on Facebook, this is the most complicated topic for me, always struggling to remember the stuff from QoS. Well, I'm hoping to simplify it a bit for you today, and then we'll dive deep on Wednesday. But again, if you want to join us on Wednesday for free and get notifications and be able to be in the chat, just go to kwtrain.com/free QoS, and we'll be seeing you Wednesday. But we want to start off by talking about how marking works and why we need marking. Now, to kind of set the stage, visualize this if you would. When I go and get on an airplane, which is less frequent these days, unfortunately, but when I go get on an airplane, I fly Delta a lot, and I've not yet reached their, I think they call it like their silver medallion status. I'm not there yet. But can you imagine the day finally comes where I get the silver medallion status and I get to get on the plane early, and I go up to the gate agent and I present my boarding pass, and they say, well, Mr. Wallace, before you can get on the plane, can you prove to us that you're really a frequent flyer? Can you produce the boarding pass from the time you went to San Jose and to Austin and to Orlando and all these different places? No, that would not be very efficient, would it? No, instead, there's a marking. I don't remember what it says, something like sky priority, or there's some sort of marking on the boarding pass itself, so maybe one of you guys know, and that is going to allow them to recognize immediately that I'm going to be able to get on the plane early because I've met that qualification. Well, that's really what a quality of service marking does. A quality of service marking it consists of bits that we put on a frame or we place on a packet, and those bits are going to identify the relative priority of that traffic versus other traffic. So in other words, when a frame or a packet reaches a switch or it reaches a router, we don't have to reclassify it. We don't have to run it through some sort of an access list. No, we just very quickly, very efficiently take a look at that marking, and we make a forwarding decision or a dropping decision based on that marking. And that's what we want to talk about today. We want to talk about layer 2 markings and layer 3 markings, and we're going to say that the main emphasis is going to be on the math behind the layer 3 markings. But first, let's take a look at our layer 2 markings. Let's say we've got a .1Q frame going over a trunk. Now we know that on a .1Q frame, in fact, you tell me, a little pop quiz here, how many bytes get added to a frame if it's going over a .1Q trunk, assuming it's not in the native VLAN? Go ahead and chat your answer in. I'm looking at the chats if you would. And Facebook takes a little bit longer than YouTube, by the way, so I might not see your answer on Facebook as quickly. But yeah, Robert Lopez, first one in with the correct answer. Robert says, and Evan also says 4. Yeah, we're going to add 4 bytes to that frame. Well, inside of those 4 bytes, there are 3 bits called the class of service, or the COS. Some people pronounce them the COS bytes, or the COS bits, 3 bits that represent the class of service. Now let's do some math. 2 raised to the power of 3 is 8. And that means we've got 8 different possible values that we could set for this quality of service marking. However, Cisco has a rule. Cisco says, thou shalt not use the values of 6 or 7. You see, the valid range is 0 through 7, but Cisco says do not use 6 or 7 because those values are reserved for network use. So that means the highest value that we can give something, that's going to be a 5. In fact, let me show you this IP phone that I have over here. This is a Cisco 8865 IP phone. And right out of the phone, when this goes into the switch, it automatically marks voice frames with a COS value of a 5. However, there's a bit of a challenge with layer 2 markings, and that is, what do you think happens when a layer 2 marking hits a router? Think about a MAC address. What happens to a MAC address on a frame when it hits a router and the router has to forward it on? What happens to that MAC address? It gets rewritten, doesn't it? It completely strips it off and it rewrites it and then it sends it off. Same thing happens with our layer 2 markings. We're going to take that QoS value of a 5 and remark it to a 0 by default. So we don't want that. We want to somehow take our layer 2 marking and convert it into a layer 3 marking. And at layer 3, we're going to have not a frame, but a packet. And if we're dealing with an IP version 4 packet, we have a byte called the TOS byte, the type of service byte. A byte, of course, has 8 bits. Now, similar thing, it's called the traffic class byte if we're in IP version 6, but either one, we've got an extra byte that's there for priority markings. Now, going back many, many years, I mean, like decades, the old way of marking used to be to use the 3 leftmost bits in that TOS byte. Again, 2 raised to the power of 3 is 8. Again, Cisco says do not use 6 or 7, and that meant the valid ranges of priority that we could use would be 0 through 5. And that marking where we used the 3 leftmost bits, that was called an IP precedence marking. So in your notes, you might want to jot down that the legacy layer 3 marking was called IP precedence. And you might say, what's wrong with that? Well, it's not really granular enough. We've only got 6 different classes of traffic that we can define, 6 different markings. You see, Cisco has a design rule, another great little thing to jot in your notes. Cisco says when we're classifying traffic, we should create no more than 11 classes of traffic. Because if everyone is special, then nobody is special. We should create no more than 11 classes. Okay, cool. Except IP precedence only lets me mark 6 different markings, so it's not enough. What do we want to do instead? Well, instead of using IP precedence, what we do today is use DSCP. For your notes, DSCP stands for the Differentiated Services Code Point. And it uses, as you can see on screen, it uses the 6 leftmost bits of the TOS byte. 2 raised to the power of 6 is 64. Now we've got values in the range of 0 through 63. Well, that's almost too many. Here's what I mean by that. Let's say that on my network, I say that a value of 26. Yeah, that's my ultimate traffic. That's my platinum high priority traffic, and I send it over to your network. And you say, on my network, 26 is dirt. I like 33. That's what's high priority on my network. You see the challenge? There's no relative level of priority between our networks because there are too many values to pick from. So the IETF, the standards body, they did us a huge favor. The IETF came along and they pre-selected 21 different values, and that's where the focus is going to be today on that math. It's going to be on 21 different DSCP values, and the IETF gave these different values names, and they call them, for your notes, PHBs, per hop behaviors, because that marking can change the behavior of a packet at each hop along its path. So we're going to take a look at those 21 per hop behaviors, and I want to show you the binary math of what those binary 0s and 1s mean. They've got a very specific meaning. So we're going to take a look in depth at DSCP, and I'm going to hop out to a whiteboard. In fact, I'm going to go full screen so you can see it a bit better. Let me pop out to this whiteboard. There we go, full screen. And let me just jot down for you some of these 21 different values. I'm going to give you, first of all, the name. I'll give you the decimal value. And I'll give you the binary value. Let's start with the high priority traffic. This would be voice as an example. In fact, that Cisco IP phone I showed you a moment ago, out of the phone, if we were to take a look at one of those packets, we did a packet capture, you would see that those voice packets were marked with a value of EF For your notes, that stands for expedited forwarding. That's some of our highest priority traffic. Now, the decimal value for that is 46. Now, what does 46 look like in binary? I'll do just the assumption is most people here know how to do binary to decimal conversions, but if not, let me give you just a quick primer on that. We're going to create, since we're dealing with 6 bits, I'm going to create 6 different columns where I'm going to put ones and zeros, and I'm going to start at the right, and it's just the powers of 2. Now, what is the power, or what is 2 to the power of 0? What is anything to the power of 0? It's a 1. So what is 2 to the power of 1? It's 2. 2 to the power of 2, or 2 squared, that's 4. And we just keep writing down the powers of 2. 8, 16, 32, and I think that's 6. Yeah, 1, 2, 3, 4, 5. Yeah, that's all 6 columns. Now, let's put 46 into binary. Let's see, does 32 go into 46? Yes, it does. So I'll put a 1 there. That gives me a remainder of 14. So I go to the 16 column and I say, does 16 go into 14? No, it does not. So I put a 0 there. Does 8 go into 14? Yes, it does. So I put a 1 there and I find the difference. The difference is, let's see, 8 and 14, that would be 6. So does 4 go into 6? Yes, it does. What's the difference? 2. Does 2 go into 2? Yes, it does. So I'll put a 1 there, and that leaves me a remainder of 0, and no, 1 does not go into 0. So in binary, that's what a 46 looks like. Now, here's the key. You ready for this? What if I sent you this EF marking? I marked a value of 46 on my packet, and I sent it to your router, but here's the twist. Your router only speaks IP precedence. What's going to happen? Is it going to look at this frame and our packet and say, I don't speak DSCP, I only speak IP precedence. Discard, I'm going to ignore this. No, IP precedence is looking at the 3 leftmost bits in this toss byte. And if we look at those 3 bits in isolation, 1, 0, 1, what is 1, 0, 1? If we look at those binary bits by themselves, what is that? Well, it's a 4 plus a 1, that's a 5. That means the IP precedence equivalent value of EF is 5, which is the highest priority that we should mark with IP precedence. So you see the IETF was very deliberate, very intentional in how they selected these values. So EF, that's our high priority traffic. Now let's say that we just have default traffic. We don't have a strong opinion about it one way or the other. So let's say, in fact, there's a name, it's actually called a default. You can type this into Cisco iOS. We've got this value called default, and its decimal value is 0. And what is 0 in binary? Yeah, if we're using 6 bits, it's just, of course, all zeros. Okay, we've got 2 out of the 21, and it's not going to take as long as you think to get through these 21. But the next category of DSCP values, they're called class selector, or CS values, and they range from CS1 all the way through CS7. So there's 7 different class selector values. Now, what is the purpose in life of a class selector value? The purpose in life of a class selector value is to be purely backwards compatible with IP precedence. Now, I showed you that there was sort of some backwards compatibility with expedited forwarding. If it were to go into an IP precedence speaking router, then yeah, it would be interpreted as an IP precedence value of a 5. So that was kind of sort of similar. But if we were to capture a packet, and let's say that I mark something with a value of class selector 3 as an example, and I were to get another packet, and I marked it with an IP precedence value of a 3, you could not tell the difference. I mean, under a microscope, you could not tell the difference between those 2 markings. They are bit for bit identical. Here's what I mean. Class selector 3, and I'm going to do the binary first because I don't have the decimals memorized. We're going to calculate it. CS3 means that if I look at the 3 leftmost bits in my toss byte, it's going to be a 3. So it's going to be 0, 1, 1. Again, if we're looking at those in isolation, the columns are 1, 2, and 4. So 2 plus 4, or excuse me, 2 plus 1 is a 3. So that's going to be a 3. And the remaining 3 bits in my toss byte, they're going to be all zeros, just like with IP precedence. So like I said, the big deal with class selector is that it is purely backwards compatible. Now, what is the class selector value? Well, let's look at this. Let's put the actual column headings on it here. Let's say 1, 2, 4, 8, 16, 32. Looks like we're adding 16 and 8. It's going to be a 24. So the decimal value is 24. And we could do that exercise for each of those 7 class selector values. The point of them, again, is they're purely backwards compatible with DSCP. Or excuse me, with IP precedence. Now, let's see, we've got 1 plus 1 plus 7. That's 9 values. We have 12 values to go. And I've got another slide I want to show you for those other 12 values. That's where our main focus is going to be today. And those values are called assured forwarding values, or AF values. And here they are. This is one of the most confusing concepts that I've seen QoS students have. So I'm going to go nice and slow here, and I'm going to periodically check the Q&A to see if anybody has a specific question that I can answer for them. Here's the deal, though. There are 4 different classes of DSCP values. Notice we have class 1, 2, 3, and 4. What does the class mean? The class is the IP precedence equivalent value. So going back to my earlier scenario, if I were to send you a packet marked with any of these class 1 values, it would be interpreted as IP precedence 1. So I could send you a value of AF11, AF12, AF13. Doesn't matter if you're an IP precedence speaking router, you're going to see all of those as having an IP precedence value of a 1. Okay, what does that second number mean? So we've got, let me just pick one at random here. I'll pick, let's say AF30, no, let's pick this one, AF41. Just kind of pick that one at random. AF41. Now, we know the 4 means that is the IP precedence equivalent value. What does the 1 mean? Well, notice this column says this is low drop probability. This is medium drop probability in the second column, and then we have high drop probability. In fact, let me go back to my camera for a second. Let's see here. One second while I switch over. Yeah, take a look at this this Diet Coke bottle I have as an example. What we're going to talk about on Wednesday, we're going to talk about a quality of service mechanism called weighted random early detection. And imagine this Diet Coke bottle is the output queue on a router. So traffic is coming into the router faster than the router can send it out. So what does the router do? The router allocates some memory called a buffer or a queue, and it stores up those packets. And let's pretend that this is that queue. Well, as we're receiving packets, they start to build up higher and higher and higher. Eventually, this queue is only so big. If we put too many packets in this queue, it's going to overflow. We don't want that to happen. We'll talk about on Wednesday more than one really ugly negative side effect if this thing starts to overflow. So what do? Well, we're going to set some thresholds. I'm going to set, let's say, a minimum threshold, and I say, if we exceed this threshold, then I will introduce the possibility that I will randomly occasionally throw a packet away. Now, we're not guaranteeing that we're going to throw a packet away. We're just introducing the possibility because this is the minimum threshold. Now, as the queue keeps getting deeper, we increase the probability of discard. That probability grows and grows and grows. Let's say that this is our maximum threshold here. At the maximum threshold, we say if you exceed this threshold, there is a 100% probability that we're going to throw you away. So you see what's happening? We have these two thresholds, a minimum and a maximum threshold. And once we exceed that maximum threshold, there's a 100% probability of discard. And what we're going to do is give a different it's called a red profile, that combination of the minimum and the maximum threshold and also the probability of discard. We'll get into all that on Wednesday. I've got some graphics to show you on that on Wednesday. But for now, just understand that for these different values where we're saying low drop probability, medium, and high, I'm saying that these have different minimum thresholds. Let me take you back out to the full screen again. What we're doing is saying everybody under the low drop probability column, and that's AF 1-1, 2-1, 3-1, 4-1, it doesn't matter. We're going to say that they all have the same minimum threshold. So here is a concept that so many people struggle with because it's not intuitive. Let me see if it's intuitive for you. Let me give you this this scenario. Let's say that I have video traffic marked with a value of AF43. Let's say that I have telnet traffic and these are not best practices, I'm just making these up. Let's say I have telnet traffic marked with AF22, and let's say that I have web traffic. I'll say HTTP marked with AF11. Now imagine that queue is starting to fill up. My question to you, to put in the comments area if you would, my question to you is that as this queue starts to fill up, which is the first application or protocol that's going to be discarded? Who's going to be dropped first? HTTP, Telnet, or video? Go ahead and chat that in if you would. What do you think? See, question saying, we can use weighted red to avoid congestion and avoid tail drop. That is correct. However, we're causing tail drop by itself. Wow, okay, you guys are all over it, and gals are all over it. Fantastic. I've had so many students in the past, and yeah, I'm seeing people on Facebook now coming in with the correct answer. Maurice and Kami saying video. Yeah, pretty much everybody's getting it. Now, a lot of people get thrown by the fact that it's class 4. I've had a lot of students actually get upset with me about this, but I promise this is the way it works. I've had students say, but no, that's a higher priority. It's on the equivalent IP precedence of 4. That's higher. That's higher than any of these others. Here's the big point. Please hear me on this. The drop probability has nothing, absolutely nothing to do with that first number. It has nothing to do with the class we're in. It has nothing to do, in other words, with the IP precedence value. The drop probability is entirely determined by that second number. So if it ends in a 1, it's going to be dropped later than any of those values that end in a 2. And those are going to be dropped later than any of those values that end in a 3. If you end in a 3, you're the first to go. Your minimum threshold is the lowest. Now, let's get back to the math here, because I've got a couple of challenges for you here in a moment. Let's take AF41 and see how this breaks down and see what that means. Remember, the 1 means low drop probability. The 4 means this is the IP precedence equivalent value. Oh, I forgot to write the F there. Let me try that again. It's AF, assured forwarding, 41. Now, we've got 6 bits. Here's the way this works. We're going to take the first 3 bits, the 3 leftmost bits, and we're going to make those equal a 4 in this case. So that's going to be 1, 0, 0. That's the first 3 bits in my toss byte. Now, if I look at those in isolation, that's a 4. Now, here's the key. The next 2 bits, not 3, the next 2 bits make up this second value. So the 4 gets translated here. The 1 gets translated using 2 bits. So that's going to be a 0 and a 1, which in decimal, if we look at those two in isolation, that's a 1. And remember, I told you the IETF pre-selected 21 values. All those values have something in common. Everyone, I don't care if it's default, expedited forwarding, class select, or assured forwarding, doesn't matter. Every single one of those values have a 0 as the 6th bit. If you look in binary at a QoS marking, a DSCP marking, and it doesn't have a 0 in that 6th bit, It's not one of the IETF per hop behaviors. But here's how that 41 breaks down. Now let's convert that into decimal. Let's write out our column headers again. We've got a 32, 16, 8, 4, 2, 1. And our binary bits that we just calculated are 1, 0, 0, 0, 1, 0. Let's add up the column headings that have a 1 under them. That's a 32 plus 2. 32 plus 2 is 34. That's the reason down here with AF41, that's the reason this says 34. Because we're looking at 6 bits at a time. The first 3 bits, that's the class. The next 2 bits indicate the drop probability, 1 being the lowest drop probability, and that last bit is always a 0. Let's see, my tablet's not working, not responding great. Let me try that again. It's always a 0. That's how it works, folks. Now, I want to challenge you because I realize this is not super intuitive when you first look at it. So I want to challenge you with a couple of examples here. Here's your first pop quiz. I'll come back on screen for you. I want you to tell me in the chat, please don't look at anyone else's answers, but I want you to tell me what is the decimal equivalent of CS5. By the way, Cisco iOS switches and routers, they'll accept either the name that you can type in CS5 or you can type in the decimal equivalent. I'm asking you now, what is that decimal equivalent? Go ahead and chat that in if you would. And I'll give you a few moments to chat in your answer, then we'll go back out to the whiteboard and we'll do it together. CS5, what do you think? Starting this, Evan's got an answer coming in already. That was really quick. Awesome. Brian, oh, good. It's always a good trend when people agree. Yeah, Evan and Brian are agreeing on the value. And again, Facebook is a bit more delayed. It's like 35 seconds behind, so it takes a moment for me to see that. Yeah. Pretty much everybody agreeing now. Awesome, awesome. Let's. Almost everybody's saying 40. You guys are doing fantastic. You didn't know this morning that you were going to be challenged with a quality of service math problem, and you have risen to the challenge. Fantastic. Let's do it together though. Let me clear this off. And let's do CS5. CS5, remember the 5 comes from the 3 leftmost bits of the toss byte. So what is a 5 in binary? If we're just using 3 bits, it's a 1, 0, 1. Because if we're looking at 3 bits by themselves, our headers here, column headers, are 4, 2, and 1. So 4 plus 1 equals 5. And we said with class selector, we are bit for bit identical to an IP precedence value, which means the remaining 3 bits are zeros. That means our full binary string is 1, 0, 1, which equals 5 if we were to stop there, but then we've got 3 more zeros, just like we would have with IP precedence. And if we write our powers of 2 up again, 1, 2, 4, 8, 16, 32, and we say 32 plus 8, yeah, as almost everyone said, that's a 40. Excellent, excellent job. I've got another challenge for you. One second while I switch back over. Here we go. What is the DSCP name for a decimal value of 22? So before I gave you the per hop behavior name and said, give me the decimal value. Now I'm giving you the decimal value and say, tell me the per hop behavior name. Now, by the way, this could be tricky. This could be a value that doesn't have a per hop behavior name. I mean, there are 64 values, but there are only 21 per hop behaviors. So maybe I tried to trick you and it doesn't even have a name. If it ends in a 0, if you write this out in binary and it ends in a 0, it's definitely not an IETF per hop behavior name. Wow, a lot of people have already got the answer in before even finished explaining it. Awesome job. Give you everybody a few more moments. Taking a look at the Facebook responses. All right, let's do it together, shall we? Let's go back out to our whiteboard. I'll clear this off. And I gave you a value, a decimal value of 22. Let's write that in binary, shall we? Let's write our 6 powers of 2. 2 to the 0 is a 1. 2 to the 1 is a 2. 2 to the 2 is a 4. 2 to the 2 cubed is an 8. 2 to the 4th is 16. 2 to the 5th is 32. 2 to the 6th, actually, I skipped one there, didn't I? Let's see, 1, 2, 4, 8, 16, 32. No, that's it. That's it. So 22. Does 32 go into 22? No, it does not. So we put a 0 and move on. Does 16 go into 22? Yes, it does. So we put a 1 there and we find the difference. What is the difference between 16 and 22? 6. Does 6 or does 8 go into 6? No, it doesn't. We put a 0 there and move on. Does 4 go into 6? Yes, it does. We put a 1 there and say, what's the difference? Well, 6 minus 4 is 2. Does 2 go into 2? Yes, it does. And it leaves a remainder of 0. So that last bit is a 0. So this is what we have. We're looking at these 4th and 5th bits. If we looked at those in isolation, those would be a 3. If we looked at the first 3 bits in isolation, that would be a 2. Now, I know that this is not expedited forwarding because expedited forwarding would have a 5 in those 3 leftmost bits. There is no class or drop probability with that. We just say, no, if it's a 46, it's expedited forwarding. So we know it's not expedited forwarding because these first 3 bits don't equate to a 5. We know it's not class selector because the last 3 bits are not zeros. We know it's not default because they're not all zeros. So that leaves us asking, could this be an assured forwarding value? Well, we break it down and it looks like it could. Its assured forwarding value, as most of you said, if not all of you, 23. Great work. Great work. Now, again, we've gone through some math together today. On Wednesday, we're going to get a little bit deeper into what the implications are for these drop probabilities. We'll get into the different weighted red profiles, and we'll get into how we can even use the 7th and 8th bits in that toss byte. Right now, we've just used 6 of them. We can actually use the 7th and 8th bit for something. Again, that full masterclass, if you joined us a little bit late, that's going to be kicking off Wednesday at 2 p.m. Eastern Standard Time. That's GMT-5. And just go to kwtrain.com/free QoS. And as the name implies, it's free. No charge at all. If you missed the beginning of the class today, I just want to let you understand what's happening on Wednesday. I'm actually recording a real course that I'm going to be selling later, and I thought as long as I'm recording it, I do this from time to time. I'll let anybody that follows my channels, I'll let them watch for free. So you're welcome to do that. Go ahead and just tune in, and you can watch for free. Now, obviously, there's no replay because I really am creating a course. I really am going to be reselling it. So, yeah, no replay. But, hey, if you can make it, awesome. You can just show up and you can watch for free. Any questions before we tune out today? Any questions at all? Let's see, given just a few seconds because there is that delay as we talked about. How important is it to know the match for this exam? Well, remember, the topic appears on both the CCNA and the Encore exam. I typically like my students to know topics more than they need to know for the exam. So my intent in the masterclass is to teach you more than you need to know. Now, I'm not going to say that, non-disclosure reasons, I cannot say you're going to be asked this QoS question and this QoS question. I just want to say that if you attend and if you totally understand everything we talk about on Wednesday, you're going to know everything you need to know for the exam. Somebody said, sorry, I missed the live session today. Oh, no worries. This will be on replay. I will let this be on replay for the next day or so. But yeah, just hopped on here real quick. I thought I'd do a little primer. Actually, I was kind of wanting to test out some new software I'm using to stream to both Facebook and to YouTube at the same time. It seemed to work out pretty well from what I'm seeing. But just see if we have any other questions. Will you cover how software buffers interface with hardware buffers? We will talk about queuing and we will talk about buffers, not really software versus hardware. The most we're going to get into buffers is, but the thing is, buffers and queuing, they're very hardware specific. So I'm going to take as an example a Cisco Catalyst 3750 series switch. It has 2 queues as its input queues, and you can have 4 queues as the output queues. Queue number 1 of those 4 can be marked as a priority queue. We're going to go in there and I will show you how to configure the priority queue. I'll show you how to configure 3 different thresholds on each of those queues. I'll discuss the difference between shaped round robin and shared round robin and show you how to configure each one of those. We're going to get really at the CCIE level when it comes to QoS. We'll start out simple. We'll start out simple with a lot of stories, and I'll do some Star Trek impressions for you. But yeah, we're going to get really, really deep on Wednesday. Let's see. Oh, you're very welcome. Let's see. Any update? Just looking through some of the questions here. All right. Lots of thank yous coming in. All right. Don't see any QoS related questions that are outstanding right now, so I don't want to. Oh yeah, and somebody's saying, Marie says, see you Wednesday. Yeah, I hope I see everyone here on Wednesday. Again, 2 p.m. Eastern Standard Time. It's free. Show up, watch for free. It's probably going to run 3 to 4 hours. I think it's going to be awesome because a little secret about me, I'm the only person that I know of that fits in this category. QoS is my favorite Cisco topic. Of all topics, QoS, that's my jam. I used to teach an 18-hour course just on quality of service, and I just kind of love it. So I'm anxious to share it with you on Wednesday. Just take a look for any other last-minute questions. You're very welcome. All right. We're going to cover troubleshooting. We're not going to cover troubleshooting. It's sort of difficult to come up with a troubleshooting scenario for QoS. Normally it's a IP telephony troubleshooting issue where the specific issue is QoS. So it's normally a broader issue that we're troubleshooting, and without giving any background into those technologies, it's difficult to pull out a troubleshooting exercise for a class like this. Hope that makes sense. All right. Oh, thanks for the kind comments. I really appreciate it. We'll go ahead and sign off here right now. Hope you enjoyed today's session, and I look forward to seeing you, if you can make it, on Wednesday. Take care, everyone.